In this lesson, we shall talk about introduction to integration. So, to get the idea of integration, let's go back to differentiation, okay? So, consider three curves, all right? They are really similar. The only thing that is different is the constant, okay? This is plus 1 minus 2 plus 10. Right, so I said we'll go back to differentiation. So let's say we want to differentiate every single curve. What would we get? So in this case, we'll get 3x squared, we'll get 3x squared, we'll get 3x squared, right? So this is the gradient function of each curve, 3x squared. Now, the idea of integration is trying to go back to these curves given the differentiation or given the gradient function, okay? So we can boldly say that integration is the reverse of differentiation. So now let's see how we can reverse from this state to any of these states, okay? So let's do that. Now, in order to reverse, we use this sign, okay? This sign is called the integral sign, all right? The integral sign. So, if you see the integral sign and then you see, let's say 3x squared dx, what this tells you is that you are going to integrate 3x squared, all right? That is what you are going to do. Now, how do we integrate? Let's go and borrow an idea from differentiation. Remember that before we got 3x squared, we subtracted 1 from the power, okay? So that is how come we got 2. And also we used the power to multiply the coefficient here, okay? So we added, we subtracted 1 and also we multiplied, okay, by the coefficient here. And we are going to do the direct opposite. We are going to add to the power and then we are going to divide the coefficient, okay? Instead of multiplying by 3, we rather divide. So let's do that here. Now this is 2, so we are going to add 1, okay? Instead of subtracting 1 in differentiation, we do the opposite in integration, so we add 1, right? Then whatever you have as the exponent, that becomes your denominator, okay? So you divide by 2 plus 1. Then you add a constant c, and I'll tell you about this constant c, okay, in a moment's time. So this will give us 3x cubed, all divided by 3, okay, plus c. Then we can simplify, right? These 3 will cancel out. So we have y equals x cubed plus c. Good. So now this c is the constant that could be any of these, okay? Could be any of these, all right? All right. So how do we determine c? Is it going to be plus 1, minus 2, or plus 10? Well, c will be determined if you know any point that lies on this curve, all right? So if you know, say, a point which is 1, 2, where the x is 1 and then the y is 2, then you could solve for c, all right? So that is how we determine the c. But once you don't know what any point that lies on the curve, then please represent your final answer in this form. So when you have an integration that comes with plus c, we call that one indefinite integral, okay? Indefinite integral. Why? Because it could have any number, could be c, any given number could be c. So you have indefinite possible outcomes for c. Right, so what is the general formula for integration? So that whichever function that we see, we'll be able to integrate. So when you are given a differentiation, okay, a gradient function, all that we do is to add 1 to the power and then divide by what the power is, okay, n plus 1. Then we will add a constant c. This is the idea of integration. So now let's practice with some questions. Given that we have 7x raised to the power 6, okay, we want to find y. It means we want to go back from dy dx to y, and that is integration. Going back is integration. So let's integrate this. Now we would have to add 1 to the power, so that would be 6 plus 1. Then we divide by what the power is, which is 6 plus 1. So we will get 7x raised to the power 7, or divided by 7. Then we will cancel out with the 7, okay? So we have x raised to the power 7 plus c. Now let's consider this question, which is dy dx is giving us 4 over x squared. Now you want to find y. So it will be best for you to represent it in this way so that you can easily add the 1 and you'll be good to go. And from 4 over x squared to this, we employ our knowledge of indices, okay? So if you do not know indices, then you have to go back before you will understand what we've done. But I'm so sure that as you have reached this stage in calculus, you already know how to move from this stage to that stage. Right, so we are now going to add 1 to the power. Okay, so we add 1 to the power, and whatever we have here, always remember that whatever the power is, that is what becomes your denominator. All right. Okay, so we clean up. Now negative 2 plus 1 is negative 1. All right, so that will make this entire thing negative 4. Okay, so we have negative 4 x raised to the power negative 1. Right, you can leave it this way, or you can make it look a bit nice, okay, by saying that this x raised to the power negative 1 will become the denominator, and then you can end it this way, which is really nice. Now when you are given this to integrate, I would advise you to expand this bracket, okay? So x times x will give you x squared, x times 5 will be 5x, 2 times x, that will be 2x, 2 times 10, 2 times 5 will give you 10, right? So you have x squared, and then you have 7x plus 10, okay? So that is what we have. Now we can integrate this. We add 1 here, we add 1 there, and then I'll talk about this. So when you add 1 to 2, you have 3, so you divide by 3. When you add 1 to the already 1 here, you have 2, then you divide by 2. Now remember that this 10, okay, has the x part, but its exponent is 0. So when you add 1, you have x raised to the power 1, right? So you divide by 1, which is the same thing. So there's a rule in integration that states that when you integrate a constant, you will get a function like this, okay? You just add x to it and you are good to go. Then you add plus c. We are adding plus c because we do not have the lower limit and the upper limit here, okay? In a separate video, I will cover definite integrals, and you will know why in definite integrals we do not bring c here. But if you are integrating and there is no number here or there, you must bring the constant c. How about this? Yes, it would be nice for you to expand this as well, okay? So that is what we will do. So when we expand this, first expand this bracket, okay? And the answer you will get, multiply each by x. So this is what you should get, x cubed minus 2x squared plus x. Then you integrate, you add 1 to this, you get 4, you divide by 4. You add 1 to this 2, you get 3, okay, the power becomes 3, you divide by 3. This has power 1 already, so you add 1 to that, you get power 2, and then you divide by 2. Then don't forget to bring your plus c, since this is an indefinite integral. How about this? So in this case, you could see that both 4x squared and negative 3 root x share x, okay? X is common to all. so you can simplify before you start your integration. It is always good to look at the question regardless of the integration sign. Okay, if this had been a normal algebra that you are asked to simplify, yes, you would have simplified. So indeed, try to simplify before you integrate. So when we are to simplify, like I said, this x affects both. So you have 4x squared over x, then you have 3x. Now root x means x raised to the power half. Okay, keep that one in mind. Right, so this will cancel that, and then this has a power of 1. Since they are dividing, it will subtract, so you have negative half as the power. Now we integrate. We will add 1 to the already 1 here, so we have 2. We divide by 2. When you add 1 to negative half, you get half, and then you divide by half. Right, so simplifying, what do we get? We have 2 minus 6x raised to the power half plus c. Well, since the question came in root x, yeah, instead of leaving it this way, we would want to write root x, okay? But you could leave it this way, that's also fine.